solar panel what overview. So I've talked about the solar panel last week. And I said the solar panel is what is the number one component that we use to do what, to harvest our what power, right, from the sun. The solar panel is exposed to what, the sun. The sun gives us two things. One, the sun produces what, light, and secondly what, heat. So a combination of these two, an explosion of our solar panel will generate our DC electricity or DC power in form of what, direct current. And this power is being what, is being passed through a device called the charge controller. From there, charge controller work is to regulate and see everything that the panel is bringing and do what, pass it down to what, to our battery. Are we together? The battery is an electrochemical device that stores charges, that stores energy. So when this panel brings this power, battery receive it and it stores it as what, form of energy. So that when the energy is stored, you can come anytime you feel like, or you want to use the system, put on the system, then you start using the energy that was stored on that battery through the help of the inverter. And the inverter converts it from DC to what, AC. Do you understand? So I've said that the inverter, I said the solar panel, I said the principle of operation, which I just talked about now. I talked about the types of solar panels, which are what? The monocrystalline and the polycrystalline. And I said that two of them are from the same family, which is the crystalline family. Then the mono, which is this type of panel, are made from one pure silicon materials. Then one of the differences is that the mono are usually what are their color? They are found in black colors, right? And they are separated with squares around them. So, and I said this one is a cell, this is a cell, this is a cell, this is a cell, and each cell is made up of 0.5 volt. So sometimes when you want to get the total power rating of this panel, you can multiply 0.5 volt times their number of cells. This one is 6 cells and 9 cells down. If you multiply 6 times 9, it will give you 72 cells. You multiply 0.5 times 72, will give you about 36 volts on voltage. Hello? You understand? So I also talk about the poly. The poly panel is that panel that just run down straight lines. There is no demarcation, there is no star in between, there's no square in between them, right? Then I said the mono panel is more efficient than what? The poly panel. Mono panel are used when you are having enough solar irradiance, when you have enough sunlight. And who can tell me the maximum number of hours or peak sun hours we have in Nigeria? Our peak sun hours, what is the number of hours that we experience? When I say peak, that is high sun now, when the sun is high. 5 hours. So, all right, so we use 5 hours. So I said the other day that when you are doing solar system, you do what? You do design. Is that not so? Then the second phase is installation. The third phase is maintenance. So in the process of you doing design, we use the 5 hours. We use the 5 hours into our calculation, because when somebody reaches out to you, we ask questions, what are the appliances? You take your load inventory, then ask the person, because the number of hours the person wants to use that load on the system determines. Hello? What you want to power or use on the solar system determines the size of inverter that you buy or you will get. How long your load will stay on the solar system determines on your battery. Hello? How fast your battery will charge determines on what? Your panel. Are we getting it? So somebody was talking about that should give a block diagram of how the solar system works. A block diagram is, we have one here, which is where we have the what? The panels. The panels goes to what? Charge controller. Right? So then the charge controller, are we getting it? Goes to what? Goes to battery. Then from the battery it goes to what? Your inverter. Then from your inverter it goes to what? Your house. Let's just say your house. Your load. Are we getting it? So this is how the system is. So from one to the other. So if you are designing a system and you get any of these steps you get any of this step wrong, maybe you have, or let's say from your battery, you have enough panel to charge your battery, but the battery is not big enough to handle those loads for 5 hours or 8 hours or 10 hours. You have failed in that aspect of battery. It's not about your aesthetics or how the work is. Maybe your panel, the way you arrange the panel, they are accurate, they are straight, they are fine. Then when they come to the aesthetics of the inverter on the wall and the battery, everything is fine, but the system is not lasting. Somebody that just go there to just do work, the wire is there, this is there, everything is scattered, though it's not a way, professional way to promote your work. I'm trying to say that in all you do, there must be a balance to the system. Hello, this aspect comes from the place of design. If you get anything wrong, you have the entire system will be messed up. You can do a design, like somebody in Lagos can do a design, or Abuja or Port Harcourt can do a design and send for me here. Maybe the person have the work, he have his own engineer, but the engineer cannot travel down from another place to this place. He can give me the design, tell me what to do, and I will go there and do the work. When you want to relate design, even our life is also design, because you have from one state to the other, maybe age bracket or your target, you have what you want to achieve, you have what you want to do at that particular time. You plan for this service to come, that is why you are here. Is that not true? These are what design. So in this system, we don't play with design. The road that have been built, these houses, even before this house was erected, there has been a plan. Even electrical system, we have design. They can give me a plan of this hall, even if I'm not here. I can use that plan to interpret and bring out electrical fittings, electrical quotation from just seeing the plan. Are we getting it? So we don't play with design at all. So another thing I'll talk about the difference between the mono and the poly. In the north, we have more sun than in the east here. Is that not so? So you can even decide to use poly over there because sun will be always much. But in terms of using mono here, even we just seeing even just light rays or a little bit of heat, this mono start conducting. The poly also conducts, so you should not be deceived that poly does not work. Poly works, but where you are struggling to have a good amount of sun, mono will be the best configuration. Are we together? Hello. So that is one of the aspects that we need to consider. I talk about the wattage. I said solar panels are rated in wattage. As I'm writing off solar panel now, I'm going to charge controller. I said something about wattage. That solar panel are rated in what? Watts. We have 100 watts. In fact, we have 50 watts because this panel is what? This panel is what? This panel is 50 watts. Right? We have 50 watts. We have 100 watts. We have what? 150, 200. Up now, we have about 7 and something watts. I believe before this year runs out, we'll be having about 1,000 watts. And those one of higher wattage, so most of them are taller than me. Yeah. So if you want to carry those panels, you know what to do. So those panels generally are rated in watts. So each of the wattage you are getting, they have voltage and current, because when you are talking about power, you can't separate voltage and current. Is that not so? What is the formula for power generally? What is the formula for power? I can't hear you. P is equals to. So when we say power, when we say formula for power is P is equals to IV. So when we say P is equals to IV, P is power, right? Then V is voltage, I is current. Because when we begin to dive into the training, you will not begin to see, we will not talk about 40 volt, 10 amps, 50 volt, 5 amps. Maybe you'll not be seeing V and A, you'll not be asking me what is A, what is V. No. In as far as I'm trying to cut corners, giving you the insight of all the aspects of the solar system concerning panel, you should understand what I mean by power. Because this is the bedrock and the foundation of what the solar setup. Are we together? Then I said a panel of 50 watts, its voltage and current might not be the same with a panel of 150 or 200 watts. Is that not so? And the bigger the panel, the higher the power ratings. The bigger the panel, the bigger the voltage, the bigger the current. So sometimes if like we have panel of let's say 600, we have panel of 300 watts, we have panel of 600 watts. Are we together? So sometimes you will see that in a place that you don't have space, because When you install two panels and one, the space will not be the same. Irrespective of this 300 watts might look a little bit smaller, but it's the space that these two panels will enter must be bigger than the space that this one panel will enter. Apart from, but big panel produce more power in terms of voltage and current, right? They also occupy lesser space. So instead of going for 10 panels of 200, 250 or 300 watts, you can try to go for 600 watt panel, maybe 5 pieces or 6. You have to, it will accommodate that space very well. Are we together? So that's one thing we need to look into when you are dealing with what? Solar panels. And also the price is different. For example, 300 watt panel might be 65 or 70,000, while this 600 watts will be around 120,000 or maybe 115, depends on your plug, where you are buying from. Hello? But the performance are not the same, right? So it's always advisable, if you have the money off, you're talking to your client to get the best out of every system, let them go for a big solar panel. Are we together? Yeah. So, and I said, this panel you are seeing comprises of how many layers? 6 layers. This panel you are seeing comprises of what? 6 layers, right? There's a glass here. There's a gum that is called encapsular gum, right? We have the cells that was gummed to the main frame, and you are seeing a white, something like a white like this, right? Then at the back, you can see we have another layer. Then this one you are seeing here is what? Is a bus bar, or we can call it a junction bus, because all these cells you are seeing, they are connected series parallel. Are we together? So if we have time, we'll be talking about types of connection, because we connect, believe it or not, those panels you are seeing up there, like those 2 panels on the roof in that clinic building, they are connected in that series or parallel. So they are what we achieve in doing this series, in doing this parallel, in doing this series parallel, because you are generating power to charge something, to store somewhere. And I told you the other day that nameplate cannot be over or underlooked. Is that not so? Because if you didn't know the specification of that particular device and you give it higher power than the old capacity, you will end up burning that system. Hello? We have went for a solution one day, and I saw charge controller that burnt my face. Hello? So we connected the panel and everything. So the capacity, we didn't look it well. We thought it's supposed to accommodate everything. So it works at the beginning, but right now front, it was phasing out. The writings were phasing out. So everything phased out. Everything phased out. That is how that charge controller burnt. That is why you have to know the capacity. Everything has its own capacity and their own rating. So you must have to know about this before you pick anything and want to connect wires. I told you people the other day that solar is a combination of electrical and electronics. The devices you are handling are under electronics base. While bringing wire to assemble them to connect them from one point to the other, that is under electrical. Hello? Is that clear? So having said so, I said the other day that on that panel, we have maximum watts, which is our power. We have this one is 190 watts. We have something that we call VOC. Is that also VOC? We have something that we call VMP. We have something that we call ISC. That's what we call IFP. Then we said VOC is open circuit voltage. Hello? VOC is what? Then this VOC might be something like this one. I think it should be around 40 volts. Then the VMP is around 36.6 volts. Then ISC is short circuit current. VMP is maximum power voltage. Hello? VOC is open circuit voltage. ISC is short circuit current. Current is around 2.5 amps. Then IMP is maximum power current. This one is around, let's say, this one is around 2.52, then 2.59 amps. So we denote voltage as what? V. Is that not so? If you want to denote voltage, abbreviation of voltage, we have what? Hello, what is this? So what is this? Why is this? It's also the same thing as well, current. Is that not so? So these are the things that we'll be seeing. So in case you see it, don't be confused. We are coming from here. I was talking about this. This plug is called MC4 connector. What did I say? Imaka. MC is called what? MC4 connector. So ideally, this is what will be on your panel cable. So at the back of this panel, you have like this. You have two connectors. What is the purpose? The purpose is what? Are we together? So the purpose is what? Did you hear one sound? So the purpose is, once I connected this, everything is what? So this is the purpose. So when you have this connector, you don't need to be worried. So in the other way around, when there is no connector, you can use what? You can cut the wires and connect it. But most times, we prefer connectors because I've went to trace a troubleshooting on solar system that when I get up, all the whole wires, all the whole cables have cut. So they have formed like something like ashes on that cable connection point. All of them have cut like that. Everything are just separated from each other. So there was no power, no current, no voltage coming from the solar panel. Until I go there, I have to reconnect the whole panel. That panel should be after how many 3, 4, 5 thereabout, how many years? But if the connector is there, because those panels you are seeing, those cables are exposed to sun, those internal points of connection. But you know, with this connector, sun will come, we hit it. You know the connector is inside. What is connecting the two is inside. So when the sun comes, this outer side will be able to withstand the pressure of both sun and rain. Do you understand? So in most times we prefer use connectors. But in a situation where we don't have connectors, you do what? You can cut your wires and join. You understand? Yeah. So this is what MC for connector. We have the male, we have the female. Then we also have them like this. That is 1 into 2. We have them like this, right? In this case, that's where you are connecting panels that we are doing parallel. You have three cables coming to join one. Because at the end of the connection, remember your controller, you will send cables or your inverter. You must send cable from the roof down to where your inverter will be. Is that not so? So you are permitted to only send two wires, which is, it will be in one cable, depending on the type of cable you are using, which is black and what? Black and what? So when you have many panels there, how can you connect the system to bring in one cable, one, which is, how can you connect it to bring in your negative and what? Your positive. The number one thing that will guide you up there is the knowledge. Is the knowledge. When you get the knowledge that, okay, I need to connect my 20 panels in series parallel, that also, then when you are done, this MC4, this connector, MC4 connector, maybe in 1 out, 2 out, in 1 3 out, will help you. You are bringing 3 here, you clip this 3 here. Then this one out will not be your what? Your output that will come to feed this place. You set it on neutral that will come and feed this negative. Instead of joining wire. If you have that MC4 connector, this one, maybe 2 to 1 or 1 output to many, it will help you. The connection will be simple. Hello? And this one, as I click it, I can also do what? Open it. I have a screwdriver and I can open in case of maybe I go for maintenance. I can easily open instead of you to cut it. And you know, we Africans, we like shortcuts. Is that not so? You might, this connector, they stress me. I've got the bring plier. Before you know, you don't cut. Say, I go join her later. They go. Not that the joining doesn't work, but there are peculiarities on this. The people that produce the panel, that bring this in alongside with the panel, they know what they are doing. They have been using this system before they expose it to people over here. Is that not so? So this is what you have to take note. And before we go outside, one more thing is I said this one is taken as what? Negative, and plus is a what? So we don't say negative is neutral, positive is life. This system is under what? DC. Under AC, we have neutral and life. Because whatever you are seeing on panel or battery, you'll be seeing plus, minus, plus, minus. So the system are different from each other. One is producing direct current, but that one is producing alternating current. Hello? Then, somebody was asking a question, I was saying that I've not shown how to measure solar panel. The first thing you will do when you get to site, after all this explanation I'll be giving you, is to do what? To carry your what? Sometimes, somebody in the market can sell a panel to you that he said the panel worth the power capacity of maybe 400 watts. When you go and test the real voltage, it will maybe 45 or even 30 volts. I told you people the other day that the sticker you are seeing, which will give you the specification and the details of the panel, can be changed. Hello? It can be changed entirely, or they will gum another sticker of a higher capacity on it. They might gum a sticker. They might gum a sticker of 500. Okay, this is 190. They might gum a sticker of 300 watts on the back that you don't know. Then maybe you might have done with a design using what? 300 watts or 400. So what will guide you when you get to site, it will test your panel. Now, we are talking about solar panel now. I want to teach and end everything on panel today, then enter charge controller. So after knowing what solar panel is, how they work, their power rating, their types and everything, you still need to know how to go into the field and do what? Do the other part of the installation. When you get there, you test each voltage. You might not be able to test the current rating. You test the voltage and see what the panel is bringing. VOC, I said on solar panel, are open circuit what? Voltage. Is that not so? Then when you test, open circuit voltage is when the panel is on no load. What did I say? Open circuit, when they say circuit is open, it means nothing is connected to it. So you test and see what the panel is giving, right? Maximum power voltage is where the panel is being connected. Are we together? So we test for the panel, and when you are done, maybe you connect 5 or 6 or 10 panels. You still need to test from your wire output. Hello? When you have done everything, before you come down, you have to test your final point of connection. Because sometimes you might make a mistake, and when you come down, you might want to check from the ending, and you will find out that the connection is wrong or something is not correct somewhere. So for you to be on the safer side always, you test your solar panels. After connection, you test the end point of your connection with your what? Your meter. So assuming now, if we are connecting 5 panels, or if we are connecting 4 panels of 300 watts, and each panel is giving us 50 volts. I want to connect the panel in series, which means we will have 50 volts. That times 4. It will give us what? 50 volts times 4 will give us. So in a bid to see that your panel is not giving you 150 or 140 something, you know that something is wrong somewhere. Hello? When we come to place of connecting panel in series, then in parallel, then in series parallel, I will explain on that why or where you need to connect the panel, either in series, either in parallel, either in series parallel. Are we together? Who have carried out a practical whereby you connected electric bulb, normal bulb, lapodas in series throughout? Who have maybe like 3 or 4? Who have had that experience to connect that kind of? What do you notice?
When there is an issue in one and two, others will be affected.
Okay. Then who else can share insight on that? Apart from when there is issue on the line, something will happen to the rest. What again did you notice when you power them? The 4 bulb, they shine equally. The first one will be brighter than the other one. When the other one will be brighter than the other one, because they are all sharing the same voltage. But when you connect them in parallel, they will shine the same. Hello? And the series side is that anytime something happens to one of them, other ones will go off or will go bad. So this is one of the peculiarity and the differences between all these type of connection. But we'll go inside the connection and we'll talk about them separately. I posted that video on the class. Are you in the group? Did you watch the video? Why? Time. In this same camp. So I posted that video that you guys should watch over the weekend. I have some insight of what I'll be doing, but many of you didn't watch it. Are we together? So now we're going outside. Somebody said I should talk about direction. Are we there? When you get to the site, direction matters. Position and go positioning, do what matters. Hello? Because believe it or not, you will see somebody that is top panel on this side might not harvest the same energy that somebody that is top panel on this side. The sun rise from where and set where. Is it really true? Who has done that experiment? Eh? Have you done experiment or what they have been telling us since? Eh?
Doing my compass, doing a biogas, doing a something, doing more biogas. The function of the rest is that lots of be able to do all that.
Okay, are we together? So as the sun comes from, so what will now happen to you when you install your panel on the west? When you install panel on the west, what will happen? So the panel will only produce or work not only evening when the sun cross 12:1, it will not begin to see. Then when it cross, when you stand on the east, when the sun now cross, the sun will now form a shade on the panel. Hello, are we together? So by so doing, the panel will do what? Will not conduct. So to avoid this, who can now tell me which side is perfect and best for panel installation? Maybe on the roof or anywhere. Eh? Eh? South. Somebody say south. Who again? Hello.
No.
So now you go with what your tape. Is that not so? Then, in case you want to, at least by tomorrow, maybe practical time, I bring some sample for what we used to hang our panels. You can just take the panel to that roof now, just put it there, we slip back and what and for. There are some things that we use. Sometimes we use profile, we use angle bar to hang this panel and all that. But one thing is before you go and, because I tell people everything is designed, before you go and nail your panel holder or your profile there, the first thing is to take your measurement, right? Like this now, I have to take my measurement like this. This is giving me, I can say this is 32. So if you don't know how to use tape, you have to learn how to use tape. Then I will measure it like this from down. Are you getting me? Are you getting it? This was 60. 362, is that not so? So we have now height, we have what? 62. Then on the width, we have what? Okay, we have 62 up, we have 32 by the width, which is the wideness. So if let me say you have 3 of these panels now, you have to calculate that is 32 times 3. We give you 90 watts. So whatever you are taking up there, you have to measure it. Then the reason why I measure the height is because as you are, everybody look at the roof, as you are seeing the roof now, there are places to match. There are places where you see nails. Is that not so? Yes. So there will be a base. Some people use interlock for both this side. They put it there. They have the bolt and nut to hold it and hold it. But the way I normally use, I go with angle bar, which is the L side, and the interlock. So even without tightening them at the up, whenever I've installed my L on the base, so when I bring the panel, I lay the panel on the L. The L will help to what? To hook the panel. So the other one at the up there is for me to use the bolt and not to clip each of them. That is clipping them up here together. Are you getting me? While the panel is already resting on the L side. I will try to bring that along at the L so that you guys will see it. Are we together? Yes. So that is one of the things. So that even outside somebody is looking inside to see your work, if somebody is passing and seeing everything is straight and well aligned, see, wow, this guy tried. As you see other people's work, you need to appreciate it. So behind the scene, they do many things. Not the one they post online, they don't edit them. You don't understand? So that is what that. The second thing I said, let's come out and test, right? So this for the panel. As we are testing for the panel, somebody should help us to check the side of what we get from either the north, where we are facing. Is it the east? Is it the west? Is it the east? So, are you seeing it? This is what, can we see? No, just lower it. This is the bus bar. Is that not true? Everybody can see the bus bar. All is on support. Oh yeah. See?
Yeah. Shine your eyes.
Everybody can see. So this is where these two wires come from, so that it will not be as magic. So when they have done their internal connection from this side, they send it to this place. They send it to this place, and they give you two outputs. So these two usually used to be black. You hardly see a panel that one would be red, one would be black. Though they will label it for you. Here we have minus. Here we have what? Plus. Are we together? Just hold it. Here we have minus, we have plus, right? So this is the indicator. This was the negative. This one is positive. I'm the one that just changed this blue wire to just indicate it. You do understand? Yes. Now, after knowing this, we have to test for using our multimeter. This is a digital multimeter, right? We have an analog multimeter. If you have been privileged to visit all those people that repair TV, television, all those, so they use the analog one. Analog meter have a scale, have a pointer. Now when they test it, it swings. That one is analog meter. This one is what? Digital meter. In this digital meter, they have many parameters to measure, but what concerns us here mostly is the voltage. Here we can use it to measure the voltage up to DC voltage up to 1000 volts, AC voltage up to 750 AC volts. And before you want to go and measure 1000 DC volts, you know, say you have to be extremely careful. If not, that voltage can send you from the roof down to the ground in a twinkle of an eye. Nothing go do you. You can try for, but you will sign documents. Hello. Hi. So now we have our DC voltage from 200 millivolts. Then we have the next one is 2 volt, 20 volt, 200 volt, and 1000 volts. And we all see it. Yes. And we all see it. Yes. Then again, we have AC started with 2, 20, 200, and 750. Can we all see it? So this sign, I've talked to people in the other day that DC volt is this one. You see a dash and a dot under it. That's where you know this one is DC volt. AC volt is alternating, a sign of alternative sign. This one is what? AC volt. Are you seeing it? Can we see? Can we see? Where my hand is, can you see? This one is what? AC volt. Now, the first thing to do when you on a multimeter is to test for continuity. What did I say? Continuity. When you on a meter, test for, and the place of continuity is this sound of like a speaker. Are you seeing? Yes. This sound you are seeing like a speaker. Right? You turn this one, I can take it, I can switch it wherever I want to switch it. Are you seeing it? Then when I on my meter, it might be here. Then this point you are seeing is my point of wherever I want to select it to. This point must be there. Are you seeing it? So I will turn it and bring it to this point of the speaker. So it's there now. So right? So somebody will hold it. Don't worry, I will show everybody. Let's do it bit by bit. Now, I have to, when I'm testing for continuity, continuity used to test for if the system is being connected or there's connection between two lines. If I want to test this wire end to end, I will use this continuity. Maybe there are 10 cables over there. I want to get out of the 10, they are all blacks. I want to single out one to do something. I will not connect one, maybe I can connect cable from there or wire from it to this point I am, or I can now use one. If this is my meter probe, or this thing that's called, you are saying is called probe. Probes. P-R-O. Probes. Meter probes. So I can use this one to touch one ending of that same wire. Then I can, out of the 10, I can now use this other end of this probe to touch the rest. Anyone that beep or give me a sound, I will know that that cable or that wire is that particular one that I touched over there. So I will not pick it out. So instead of me to be finding that way, multimeter will help me to fetch that line of cable. Are you getting it? Yes, so for me to see that, okay, this multimeter is working, I have to do what? To test it too. Can you hear any sound? What matters most is what? Forget the read. The read is always 0.00. But sometimes when you want to test a length of cable or wire, you might see reading on it. But what matters most as at then is your sound. Are we together? So when you get your sound, you know it's working. Now, another thing is here, I said on DC voltage, you start from 200 millivolts. Is that not so? Now I have 200, I have 2, I have 20, I have 200, I have 100. And this panel we're going to measure now is within how many volts? 50 volts. Is it 50 watts? The panel voltage should be around VOC. My VOC here is 23.18 volts, right? What I'm trying to insinuate here is that when you have this kind of, you have to select this multimeter, you select the range, right? You want to measure. You can't have something of, cannot have something you want to measure of 20, you now go and put it on 2. If you know that this panel will give you 200, you cannot even select this thing to 150. Are we getting it? Yes, so you must always go for a higher range. If possible, even despite I will measure 200 here, I will measure 20 something. I will take it up to 200. I have 200 millivolts, I have 2 volts, I have 20 volts, I have what? 1000 volts. What I'm about, even if it is 19, I cannot take it to 20 because anything can happen and it can make it increase more than that 20 or that 19 that they said this panel will give us. Even if it is 18 and you have 20 close, you go down, put it on 20, you put it above because anything can happen and let it spike up. Are we together? So now, since I measure 23, we place it on what? 200. We switch it to what? 200. See the pointer? Are you seeing it? Is it not 200? I place it. Is it not 200? On DC? Is it not 200? Have everybody seen it? This is 200 on what? DC. So the next point is that we will now use it to test the panel one after the other. So hold this multimeter for me and we'll test. We'll test one like this and like this. I'm coming. Show them this side. Show them this side first.
20 points.
Are you seeing anything on the? Do you see anything minus there?
Yes.
Who can tell me why? Okay, let me change it. I'll put this one here. I'll put this one here.
That's not true. Zero.
Now you are not seeing. I'm coming. Now you are not seeing anything reasonable, yeah? Now because you block the surface of the panel. So when you open up, no, leave. When you give the panel on, just shake back. Shit back.
Let's go right there. 24.3.
How many are seeing?
Pick up. Let's see anything. Okay.
Take.
That's
How many are you seeing?
minus. It's always
So we change the polarity because the polarity is wrong. They've just put it. Are you seeing it? Is there any polarity sign? Is there any polarity sign? So are we seeing it? Are we seeing it? Are we seeing it? All right. So this is how to measure the panel. So we have seen this one. We move over to this big one at test. So what they told us here is actually correct. Is that not so? Right. So let's move over to this one. So here we are doing the same thing, right? So this is my 2 cable, right? One of the advantage of using a meter is because of that polarity sake. Are we together? You might end up connecting maybe 20 panels or 50 panels. Maybe you are done over there. And by the time I bring cables, this cable you are seeing that we use because we have DC cables, as in you have solar cable are different from electrical AC cables. Are we together? So some of them you hardly see red and black. Are we getting it? You can see blue and black. You can see pink and you can see different colors. And one thing that should guide you is that the reason why we use red and black is because of color coding, because we are used to that system that whenever you see red in AC, you know that that thing is live wire. Whenever you see black is neutral. Under DC, whenever you see black is negative. Whenever you see red is what? Positive. But we can actually use any type of color. But because tomorrow another person might go and want to troubleshoot that system, want to maintain or work on that system. If the person is not the one that did that job, the person will be confused. He will now start troubleshooting, tracing. Where is this wire coming from? Where is this wire coming from? If not, we can decide to use any color. You understand? Now, over there was a blue cable on that panel and black. Now we have two. Now, I am not there to see that this one is negative, this one is positive, because they indicated it at the back. But in the situation whereby I sent somebody up there to do the work, he has done with the work. Then I am now down doing internal connection, hanging the batteries, hanging the panels, and all that thing. Before I will connect to anything, it's for my duty to do what? To use the meter to test the voltage. As I'm testing the voltage, the same thing I'm testing for polarity. Because if you now use two different cables, one is red and black, one is maybe pink or this other color they are close to red with brown, thank you. Then if I am using what brown, maybe along the line, the cable is not enough. We join it. One has blue and black. The other one has brown and black, or brown and blue. Then we join it along the line. It has already been twisted. It has been changed with that mixture of different color coding. So somebody use the normal one, black and red up there. Then when we change it, we now alter the color. If I put at the back of mind that black is always my positive, and that guy changed it in the point of when he was connecting it to join cable so that it can come down to our point of connection, I will do mistake and I will burn the system. You are not only checking your voltage. Multimeter is also giving you the privilege to check for what? Polarity. Are we together? So here, using my multimeter, I can know that one is negative and one is what? So somebody should look at the VOC there and tell me, hold it. Look at the VOC, tell me the VOC of the panel. 45.2 volt. Now let's give the panel sun and see what it gives us. Do this one. Are we seeing it? 39 point what? Is there any minus there? So now let's expose the panel to sun totally. Let's see if it gives us that. Clear it.
40.5.
And small.
Are you seeing it? Yeah. But it can do up to 45 and above. Are you getting it? Yeah. If I'm now holding it, I will know that if I'm connected to my charge controller, I will know this side, this red is this black. Assuming initially I place this one here, to give me, so the polarity is wrong. Are you getting me? Unless, in this case, you have to switch it. Always make sure your polarity is wrong and be careful with your wire. Are you seeing it? Because if the polarity is wrong, it will affect your charge controller. If the charge controller is not sensitive enough, it will just burn it directly. Are we together? So we have seen from the two panels and we have seen the testing. Are we done? Okay, so people that have a question, go ahead, ask your question before we proceed.
Please, my question is, how do we know the sizes of these cables?
Okay, how do you know size of cable? Okay, somebody's asking, how do you know size of cable? Solar panel cable sizing comes with the panel. You are not the one that will determine this cable, the size of cable. Unless if you are asking for the size of cable that you will use for your connection, for your installation, connecting from the roof, after connecting the panel, send down to your charge controller will be. You understand? Asking for that size, you will do that. The design also covers from the aspect of that size. During your design, you will get the number of panels. When you do a design, you arrive at, okay, I will be using 20 solar panels or 15 or 30. Now you ask yourself the question, what is the gauge or size? How many mm of wire can carry this amount of voltage and current? Are you getting me? Because when you are transmitting high voltage, you need a good or size, good amount of a better size of. Because in this one we have a 2.5 we have 4 we have a 6 we we have 10 mm, we have 16 mm, we have 25 mm and above. So the number of wires, the gauge, the size of wire that you want to use for your installations determines the amount of current and voltage you are sending out. So it's also part of the design. You understand? So who else have another question?
This probe, how do we know if you have to put black here or red here?
Okay, hello. Place the phone where you are slanting it. Place it where. Hello. So somebody asking probe. So to the case I give you this meter to go and do work. I just give you the probe. Go side and connect to everything have its own way of assimilating or connection for it to work. Are you seeing what I'm saying here? This connection, are you seeing it? Eh?
Yes.
Are you seeing this connection here? These lines.
Yes.
Are you seeing these lines here?
Yes,
these lines. Eh?
Yes, that's me.
So are you seeing these lines?
Yes.
These lines that you are seeing, I'm telling you, from here to here, there are things that will measure under this if the probe are under this two. Then if you switch it from here to here, there's something that will measure. 4 probe cannot be here, it is 2, but you have to switch it depending on what you want to measure. Then when this is from here and here, there are things you will measure. You cannot measure everything where the 2 probe are here. I'll give you additional knowledge now. Then now, common is always, black is always uncommon. Are you seeing common written?
Yes.
Can we see common?
Yes,
Common, your black probe is always common. So whatever you want to measure, depending on where you will now put the red probe. So on here, they said here, maximum 750 volts and 100 and 1000 volts on DC, 750 volts maximum on AC. So they are not telling me that this one and this one is for just voltage, continuity voltage on DC and AC. If I want to measure current, are you seeing 20 amps? 20 amps. Are you seeing 20 amps?
Yes.
If I want to measure current, I will place it here to measure current. If it is here, nothing will come up. Yeah, other meters like clamp meters that have just two ports. That one, most of them are auto select. Once you place it on DC, it can measure up to 1000 DC. Once you place it on AC, it can measure up to 750 or 1000 volt AC. But this one is a selected meter. Selecting meter, we have to select the range. But I have to make sure to select it to that point. Other meters might have only these two. That is why you have to understand the meter you're working with, because we have different meters in the market.